going to touch too much of this.
Oh, I had a question.
Sure.
Do you guys ever do any like, how would I refer it to? Like study meetups or no?
Like to pair program and things like that, or?
Like in case I have like a project I'm working on where people meet and help each other.
Not recently. I think we have done them in the past. We haven't done any recently, but that's definitely something to like that we want to get back into.
Please
Yeah.
do, because I have some assignments that I do and I'm like, what is going on?
All right, everybody. So welcome to Easier Parts Online. And on site, we have some people here. So on the count of three, we're going to welcome everybody who is online with a fun hello world. So 1, 2, 3. Hello world. All right, awesome. So this is JavaScript, the easier parts. That is a beautiful cohort here. That is Will Sentence. He is our CEO and just kind of a delightful human. And then I'm on here. So this is the Codesmith team that makes all these meetups and the program and all the things that we do here all possible. They are wonderful, lovely humans. Especially that one on the second row, third one in from the side. No big deal. But yeah, so for anybody who hasn't been to Codesmith before, we're going to talk about what is Codesmith a little bit. Codesmith is a center of software engineering excellence and a selective and tight-knit community, and really what all those things mean is that residents in our program here build full-scale production applications, typically prominent developer tools that are used by people and companies kind of all over the place. These are things like what we can see here, React Monocle, React Tide, and a ton of other things. And we get a lot of guest lecturers and guest speakers from all over, not just LA, but kind of all over the country. We've had guest lecturers come in from large companies, small companies, giving different perspectives and different talks on a lot of concepts ranging from front-end optimization to security and testing and things like that. So lots of good stuff there. And in terms of the community here in the Codesmith residency program, we have selective and tight-knit, but that doesn't mean that we are exclusive. So we love having people from all different backgrounds, whether they're some technical backgrounds or not, whether they're, really any kind of stage of life. We've had people who have PhDs in completely unrelated concepts come in and run through the program, and we've had people, straight out of high school, straight out of college, kind of still figuring out what they want to do, and yeah, so a wide range of backgrounds and all kinds of things like that. But yeah, it is selective. We have a technical interview process that is pretty rigorous. But that's really, it's not to exclude people, it's really to make sure that once you get into the program, you are ready for the program, because it is very intense. It's 12 weeks, 6 days a week. So yeah, we want to make sure that once you're in here, you're in it for the long haul, that you're really ready to succeed in the program. And so yeah, we build community leaders for life, right? So some of our outcomes for graduates are typically mid to senior level roles. That is most often what we see, the kinds of roles people in this program coming out with at companies such as the ones listed here, but also tons of other companies. And there's a full list of the companies and the outcomes for every single grad out of the program that's on our website. So highly recommend, if you're interested in that, to check it out. But really that kind of leads into, how do we get these outcomes, and how do we do that kind of thing? And really that comes into play with the pedagogy. So we don't just look for technical skills, so how much programming experience do you have coming into the program? What we really look for are analytical problem solving and technical communication, because those are foundations that you really need to have in order to succeed as a software engineer. So we build developer tools, we build real projects, we build things that people are using in the real world, which means that we produce engineers, not technicians. So you don't come into the program and we don't tell you, hey, this is how you write a React application, this is how you start up a server, this is how you do these things. We teach you the underlying concepts of what is React and why is React useful, what is Node, what are other languages you could use to write a server, and then you go off and you learn how to do that on your own, but we facilitate that learning in a structured environment. But really, it comes down to analytical problem solving and technical communication, because you do that all in pairs or groups, and so you have to be able to work with other people and be able to communicate your own technical ideas to other people. Yeah, and then supporting each other comes along with that pair programming and that technical communication, also being mindful and thoughtful when you are pairing with other people on kind of how to approach engaging with others and being mindful that some people may be at a different skill level than you, and being mindful of all of that, and being just kind of a good person in general is always a nice reminder, right? Yeah, and then again, that production level environment. So the 5 things that we look for in candidates here at Codesmith are analytical problem solving, technical communication, engineering best practices and approach, non-technical communication, and then finally at number 5, language and computer science experience. So they really are kind of listed here not just as bullet points, but really in a 1 to 5 order, because those are kind of that it really is the order in which we look for these different characteristics, right? Language and computer science experience is always something you can learn, and I mean any of these capacities are things that you can learn and grow. But we think that the most important ones to have coming into the program are analytical problem solving and technical communication, because those are the building blocks with which you facilitate the rest of these things. That and the non-technical communication, the being just a generally good person, right? And then our expectations of you, just again being that good person, working hard, and being thoughtful when you're in those groups and situations. And then how to prepare for a program like Codesmith. The best way to do that would be going on CSX, which is the online learning program that we have currently for free online. There's a ton of content on there to get you up and running, get you ready for your interview. We'll talk a little bit later about CS Prep, which is kind of our guided journey through CSX and through some of these concepts that we look for in the technical interview. And then also coming to JavaScript the Hard Parts, or joining us online for JavaScript the Hard Parts. Yeah, so meetups like this, right? Easier parts, hard parts, kind of really getting a sense for how we at Codesmith and just in general talk about technology. And then all these other things are also really great resources for doing for learning any kind of programming, but really for prepping for Codesmith as well. So finally, what you guys all came here for tonight, right? JavaScript the easier parts. This long title of things. But let's talk about principles of JavaScript just to get started, so that we all start out on the same page a little bit. So tonight we're going to talk about fundamental principles that are going to enable us to problem solve and really communicate any problem or challenge you might find when you're working in JavaScript. So it could be something very simple like declaring variables, like what we're going to talk about tonight. But really the way that we talk about these concepts tonight, you can use in any situation in JavaScript. So we can walk through, we're going to walk through these steps, step by step, line by line, the same way that JavaScript will read our code. That's how we're going to talk about it. And that's really how you can talk about it at any point in time, and even through these harder, more complex challenges. Give me just 1 second, I'm going to shut this door over here. Lots of excitement here today. It's a hiring day today, so.
Yeah, that's why everyone's.
Yeah, so they did like speed interviews all afternoon with like 15 different companies. So yeah, good times. Yeah. So that's what we're gonna do today. And so getting into it, right? Let's talk about JavaScript, right? What is JavaScript? JavaScript is that tool that we use to write instructions to tell our web browser what to do, and what to do with the content or information or interaction that happens with our web page. So up until now, maybe all you've really dealt with is HTML and CSS. So HTML being the structure, the kind of skeleton of the page, you know, the kind of different elements or features that we want to display on the page, buttons, headers, footers, things like that, the skeleton of the page, right? And then CSS is just kind of the way to style those elements on the page. We really don't get into much fun in HTML and CSS. I mean, you can have fun with that, right? But really where we get into the meat of real applications and the real fun stuff in programming is going to be in JavaScript, at least on the front end. It's going to be in JavaScript, right? Because that's where all of the interactivity for our application lives. Yeah, so it's a series of instructions and things that we can reuse and do to our application or with our application, right? If a user clicks a button, we're going to do something else now. We can listen for that event. We can do something else. So yeah, it really makes web browsers and web applications what they are today. It's exciting. So what actually happens when we talk about JavaScript running, right? It's a programming language, so it's going to run. What does that really mean? Really, all that means is that the JavaScript engine is going to go through our code line by line, and it's going to save data in memory, and then run functionality on that data later, like hopefully. I mean, you could just have a JavaScript file that all it does is save things to memory, but we'll talk about in a second why you maybe wouldn't want to do that, or why that's not really helpful at all. But yeah, so we can save information or data, and that we can then run functionality on. So we can store data in many different formats. The 4 that we're going to look at right now are just 4 examples of things that you can. There are different data types that you can store in JavaScript, but they're pretty fundamental ones. There are definitely other data types, but these are kind of the building blocks that we'll work through tonight. So before we get started on what's happening here on these 4 lines of code here, let's talk about, just in general, when we talk about running JavaScript code, because we're going to walk through tonight running JavaScript as if we are the JavaScript engine interpreting this code that somebody else has written for us. So as soon as you run a JavaScript file, let's consider these 4 lines as our JavaScript file that we're running, right? Whenever you spin up a JavaScript file, you're going to get what we're going to call an execution context. So the first kind of, the very first execution context that we're going to get when we open up a new JavaScript file, we're going to call it our global execution context. And along with this global execution context, we're going to get some memory. And we'll call that our global memory. All right. So when we talk about running our code in JavaScript in our global execution context or in an execution context, JavaScript is what we call single-threaded, which means that it can run one thing at a time. So it's going to start at the very top of our file, and we'll think about this little arrow here as our thread. And it's going to start running line by line through our code and stopping at each point in time and doing whatever that functionality tells us to do, and then moving on. But it won't move on until whatever that line says to do has resolved. So going along with this kind of this kind of knowledge in hand, we're going to run through each of these 4 lines as if we are the JavaScript engine, and we'll talk about what's happening at each of these lines. So the first thing that our JavaScript engine is going to run into is going to be this line that says const num equals 3, right? So we're going to get here, and we're going to stop. And let's talk about what this line is really saying. So in JavaScript, we have a syntax, right? And some keywords in that syntax that are going to tell the JavaScript engine, hey, this is a keyword that I know, and now I know what to do when I see this keyword. So this keyword const is going to tell the JavaScript engine, I am declaring some data that I want to store in memory with a value. So const is going to tell the JavaScript engine, I'm declaring a variable, and I'm going to give that variable a label of whatever comes next, so num, and then I'm going to assign it the value of whatever comes after the equal sign. So in this case, we have const num equals 3, so that's going to tell our JavaScript engine, okay, I'm going to declare a variable num with the label of num, and I'm going to assign it the value of 3. And all that does is that in memory, it's going to open up a space in our memory, it's going to save a label called num, and it's going to assign that label a value of 3. And that's going to be in our global memory as well. And so then what do we think is going to happen on the next line when JavaScript, so this line has now resolved, right? We have our num3 in our memory. So now we're going to move on, right? And we're going to keep going down the thread, and we're going to get to const name equals codesmith. And what do we think is going to happen at this line?
You must store in global memory a variable called name and assign it the value codesmith.
Exactly. So great, exactly. Yep, we're gonna assign a variable with the label name, the value of codesmith. Now, if we wanted to get even more specific about this, what do we think the difference is, or is there really a difference between these two lines? Does anybody see any kind of difference between the two values there?
Yeah. One is numerical and one is a word.
Yeah, one's a number and one's a word. And so when we're talking about these two different things in JavaScript, we're actually going to refer to this 3 is a number. That's the data type, the official data type in JavaScript is going to be a number. And then anything in quotes, it can be single quotes or double quotes. They have to match, obviously, but anything inside quotes is going to be a string. So that's what we're going to think about a string. So if we had const num equals 3 in quotes, that data type is going to come back as a string, not as a number. So you can have any kind of content inside of a string, and the data type there would then be a string. So it's going to kind of coerce, well, it's not going to coerce it, we're assigning it as a string. So if you think that this is a number, if it has quotes around it, it's not, to JavaScript, it's not a number. Just something to keep in mind. But yeah, those are kind of two of our data types, and we can always use this keyword, there's a keyword type of. And so if we ran after this type of name, that's going to return us, that's going to show us string. Because that will return what is the data type stored, of the value stored under this label. So it's going to go in memory, it's going to find this label name, and it's going to tell us what is the data type for the value of that label. Cool. So let's move on. So now we get into some fun stuff. So now we have, not that this wasn't fun, we're all having fun, right? So now we see const store of info, right? Equals these curly braces and some data in here, right? So now we get into the fun stuff. We're all familiar with numbers and words, or strings as we're going to call them now, but now we're getting into some JavaScript specific data types, right? So store of info, anytime we see a curly brace, a starting curly brace, along with this keyword saying we're going to declare some kind of variable, that data type is going to be an object. So these curly braces note that this is an object, and objects can have any kind of values inside of them. So objects are made up of key value pairs. So similar to how variables are kind of these label value pairs, a label with a value, objects have those keys and values inside of them so that you can have a lot of data stored inside one variable name in memory. So in this case, store of info, we're going to save some data in there about a person, probably, it looks like. A person with the name of Will, and their company is Codesmith, right? So we can kind of group data together inside of objects. So when we see this name, Will, I'm going to shorten that, Codesmith. That's going to tell JavaScript engine, right, as we get to this line, right?
Yeah.
Come back down here in our thread. We're going to get to this const store of info. It's going to tell JavaScript engine, okay, I'm going to, again, open up some space in memory for a variable with the label store of info. And its value is going to be an object. And inside that object, we're going to have one key called name, and its value is going to be Will, the string Will, and we're going to have another key with another key called company, and that value is going to be Codesmith.
I have a question.
Yeah.
So for the objects, keys replace the variable. Because, for example, on name, let's say name3, it is variable name and value 3.
Ah, excellent question. Yeah, so these two are seemingly have the same variable name, right?
Yeah.
But keys are different than variables. So a key is a property on an object, so it's actually inside this object.
Okay.
So these two things are not the same.
Oh, okay.
Yeah, so if you tried to find, so if we did type of name again, type of name, we would still get, well, let's not do type of, let's just say we wanted to look at name here, we would still get Codesmith. But if we looked at, and we're getting a little bit ahead of ourselves, but one way to access this property on the object would be to do store of info dot name. And that's going to give us Will. So you can't actually access these properties on the object outside of the object itself unless you're referencing the object.
So you'll never have variables inside objects? No.
That's a tough, not that are created through using like const.
Const.
Yeah, or let or var or anything like that, yeah. Good question. Is that a question? Okay. I just saw movement and I was moving too. Cool, so then we're gonna go and move on now to our last line in this slide, which is gonna be numbers, right? Const numbers equals, ooh, new fun bracket type, 5, 6.
Oh.
So curly braces are gonna tell us that that is an object. Square brackets are going to tell us that this is an array. So the numbers is going to be assigned a value of an array. And you can think of arrays as lists, right? So a list of elements, right? And we can have, in this case, we have the numbers 4, 5, and 6. But the elements in an array can be any data type. They can even be other objects or arrays. That's true for objects as well. The values for keys can be any data type as well. Including other objects or arrays. But when we're talking about arrays, yeah, we can still have any data type that we want. We could have 4, the number 4, the string will, and store of info could be an element in our numbers object. I mean, it wouldn't be because it's not enough, but you get the idea. Cool.
What are those called again?
Square brackets.
Okay.
Yeah. Cool. So, so objects and arrays are very similar. One thing that's not super important to know for now, but is important in the broader context of JavaScript, is that arrays are objects under the hood. They're just the keys for each element in an array is an index. So it's kind of given an automatic key. That's just like a fun thing that you get when you use an array in JavaScript. Under the hood, if you did type of numbers, it would say object. Because it is a type of object, it's just a fancy object with some additional fun methods and things like that. But that's not anything we need to worry about today, it's just a fun fact. Because it makes me happy. So yeah, so the one last thing that we're missing here, what's going to happen when JavaScript sees this line? The only person I haven't called on yet, Suzanne.
Oh. And name and numbers?
So we're going to declare a variable, right? What's its label?
Number?
Yep. And what's the value?
456.
456 stored as what?
Stored as,
What do the square brackets tell us?
arrays.
Yep, exactly. So we're going to store the value for numbers is going to be an array with the numbers 4, 5, and 6.
So the array is like summary, that word? Summary is like R-A-Y.
Yep, array. Yep.
Oh, it's A-R-R-A.
Oh, which one? Array.
Oh wait, sorry, what is it?
The spelling.
Oh yeah, A-R-R-A-Y.
Okay.
Yikes. Whew.
Thank you.
It's a day today. Cool. So, now that we have a bunch of information here, I'm going to erase it because one thing we're going to talk about now is what happens when we get to the end of our JavaScript file. What do we think happens to this memory and execution context when we're done running our file? Any ideas? What do you think happens? Come on, Agnes. What do you think?
It gives you the information, like the task you told it to do.
Yeah, it did all the tasks we told it to do. Now
Okay.
it's done.
It's done.
So it goes away. Nothing happens.
It goes away.
It goes away. Because when you're done running the file, right, there's nothing else for it to do. So it doesn't need to keep that space, that memory anywhere. We're not using it. We're not doing anything else with it. Seemingly, this is all we wanted to do was store variables, and that was it. So now we're done. We did it. And now all of this goes away. I don't like standing on my tiptoes, so I'm not going to erase the memory or the execution context labels, but everything goes away. So global memory, global execution context go away. As soon as the file is done running or the function is done running, as soon as it's returned its values or completed all the tasks in its, in its thread, then it's done and it goes away. So now we're on a new slide, therefore we have a new JavaScript file. So we can run different functionality based on specific conditions, right? So instead of just storing data, which is what we were doing here, we can store data and then we can do stuff with that data, right? So one thing that we can do with this data, or some functionality that we can run on it, is we can control what functionality gets run or what things happen based on what type of data we're looking at. So we call it control flow, and we can do this and we can facilitate this using keywords if and else in JavaScript. So these are anything you see here in green is going to be are going to be JavaScript keywords. They're telling JavaScript, hey, this is something, this is a keyword, you know what to do with the information now based on this keyword. So let's look at how we can use if-else statements to kind of control the different, or run different functionality based on some data that we already have. So let's start out with something we know, right? New JavaScript file, what's something new that we get? Hint.
A new execution context.
Yeah, a new execution context, right? So new JavaScript file, we're starting to run it, we get a new execution context and a new global memory, and now we're ready to run through our thread of execution. What's the first thing that we're going to do?
We're going to declare a constant variable migrate and assign it the value of 75.
Exactly. So in our memory, we now have a variable saved in our global memory. It's got a label migrate, and it's got a value of the number 75, right? Now we've got some new stuff happening here. We've got this if keyword, and we've got this else if keyword, and we've got this else keyword, and we've got a whole bunch of other stuff happening. So when we talk about an if statement in JavaScript, what we're really talking about is everything from that first if statement there, where it says if migrate is less than 70, and then we see these curly braces here. And we just talked about how if we see the keyword const, that's going to tell JavaScript to open up space in memory for a variable, and that data type for those curly braces is going to be an object. When we see these curly braces here after an if statement, after the condition for an if statement, that's going to be the start of our code block. So that third line there, the console log my grade is a bad grade, is only going to be run if the if condition there is true. So we're going to check if my grade is less than 70, and then we will run that code block if that statement turns out to be true. Otherwise, we're going to move on to our else if statement. So it's pretty self-explanatory here, right? If this condition is true, do this thing. Else, if this condition is true, do this thing. Else, if none of those things were true, do this by default, right? That's basically what's happening here in these three if, else statements here. So let's be the JavaScript engine again, right? We've already run through migrate. So now we're going to hit if my grade is less than 70, and is that going to be true? Sure. My grade less than 70? What is my grade?
69.
Did you just make that up? No, what's gonna so JavaScript gets to this line, right?
Yeah.
We've already hit this line, const my grade equals 75, right? And now we hit this line, if my grade is less than 70. So what's JavaScript gonna do?
It's not less, so it won't run it because it's not less than 70.
Yeah, it's not gonna run it because it's not less than 70. However, the way that we know that is that when JavaScript sees this if statement, it says, okay, I'm gonna evaluate this condition, and if it's true, I'll run this code block. Great. When it evaluates this statement, what it's actually gonna do is it's gonna go into memory, it's gonna see this label here, and it's gonna go into memory, and it's going to look for that label, right? It's going to look for somewhere in memory that it sees this my grade label. And then what it's going to do is it's like, okay, here it is right here, and it's going to pull out the value of that label and replace it. So my grade would get replaced with the value of 75. And then it will evaluate that expression, right? It's going to say, if 75 is less than 70, then run this code. But as Agnes pointed out, not going to be less than 70, so we're not going to run that code. So then it's going to check, else if my grade is greater than or equal to 70, and my grade, oh no, is less than 80, oh, yes, did it, haha. So, what's going to happen when we hit this line? Pachuda.
So JavaScript goes into global memory, checks what my grade is, evaluates that it's greater than 70.
So,
And
70, it's going to replace these though first, right?
Right.
75, 75, and then what's going to do?
It's going to evaluate that 75 is greater than 70.
Yep.
And 75 is less than 80.
Yep.
So
Is that true?
Yes.
Yep. So this is all going to turn out to be true. Yay! Yikes. There was some spelling. Great. Yeah, so this is all going to turn out to be true, right? And then what's going to happen?
Console.log.
Yep, exactly. So then we're going to actually move into that code block because this condition turned out to be true. This one wound up being a big old false, but this one's true. So we're actually going to go inside that code block and we're going to run whatever that code block is telling us to do. And in this case, that code block is telling us to console.log, my grade is a passing grade, right? And actually, I guess before we started, asked like kind of what is this console log? What does that really mean, right? And that's a great question. It's actually a little bit of a spoiler because there's a slide about that at the end, but we're talking about it now, so let's talk about it. So think about the console as something kind of completely separate from this execution context, this global memory. The console is really something for you as a developer on your browser, if you're running your code in a browser or a text editor, wherever you're running your code. This is for you to see. It's for you as a developer or somebody else as a developer looking at your code to come in and see kind of, if you wanted to console log and you're really just running this program for yourself and you just kind of want to see, is it a passing grade, is it a failing grade, things like that, right? So in this case, it would just print, it's going to print that to our console, our JavaScript console. So this is just for you as a person to look at your leisure, right? It's something for you to be able to see that value. We're going to look at a little bit at a return keyword, which is a little bit different, much different, but sometimes they're used interchangeably, and that's where sometimes, especially newer people to programming will get a little hung up on the difference between returning something versus printing it to your console. So we'll talk about that in a little bit, but just know that this console is for you as a developer to look at, and we can say, okay, so we said that it's going to now console log, so my grade is a passing grade, right? And what's it going to do when it sees this?
Replace it with 75.
Replace it with 75, right? So in the console, it's actually going to show 75 is a passing grade. Cool.
So all the other stuff, the global and global memory happens, let's say, in the JavaScript memory.
Exactly. Yep.
And
You don't
this is
see it
what I
unless
see.
you print it. Yep. You don't see it unless you print it to the console or do something else with it. Yep. Yep. So all of this stuff is happening under the hood when you run your JavaScript file, right? So you don't ever necessarily see all of this. You would never see all of this. This is just, we're going to be the JavaScript engine tonight, right? So we're going to see it because we're the JavaScript engine tonight.
Okay.
But you, as, or anybody who is not us tonight, would only see 75 as a passing grade. Cool. Cool. Great, so we've still got more in this file though, right? We've still got more stuff to do. So what's going to happen? What do we think is going to happen after we hit this else if statement and we console this we print this to the console? We are now at what line? Where are we going to go from next? We're right about, sorry, I don't know how to do this on the live stream, but basically we're right here, right?
So we're going to line 6, the else.
Ah. So yep, so I did say JavaScript goes line by line, which makes you maybe think, right, that you would then go to this else statement, right?
Yeah.
Ah, but to JavaScript, this whole if else block is kind of one statement, right? So as soon as we find something that's true, we don't do anything else in that statement anymore, because it would be kind of bad, right, if we then printed out 75 as an excellent grade.
True.
That would be confusing, right? So JavaScript is a little bit smart in that sense, right? So if we use this if keyword, it's going to evaluate everything in this statement until it finds something true,
Then it's
and then it's done. But as soon as something returns true, if this first line had returned true, we wouldn't have even looked at any of the other else if statements in that particular if statement block. When we get to if my grade is equal to 100, do we think we run that now? Some say no, most say no, some say maybe. We do, actually. So here's why. So the if keyword is telling JavaScript this is a new if statement. Only the else or else if won't get run in that statement if one of the other conditions evaluates to true. However, the standalone if keyword will tell JavaScript, okay, this is the start of a new if statement. So we're still going to evaluate that condition, even if it's using the same variables or parameters as we did before. We're still going to run that line. We're still going to check that line. We're still going to check that condition. So we're now going to check if my grade is this triple equals to 100. And what is my grade? 75, right? So that doesn't triple equal 100, right? Let's quickly talk about what the triple equals sign is there, because if we remember from this last slide, we had a single equal sign here, and that can be a little confusing because typically when we're talking about math and things like that, we're talking about a single equal sign meaning equality. So basically thinking maybe the word num is equal to the number 3. And in kind of a math sense, that's not true, obviously, right? Because num is a word and 3 is a number. When we're talking about a single, or when we're looking at a single equal sign in JavaScript, we're talking about assignment. We're going to assign this value to a label. How we check for equality in JavaScript is this triple equals or double equals. Double equals is kind of going to look for truthy, or falsy. Is it kind of true? Is it kind of false? It will try to kind of coerce data to match so that it can check for equality. So something like if we had before, like we said, string 3 and number 3, if we did double equals, that would be true. Because string 3 is kind of equal to the number 3. But if we did string 3 triple equals the number 3, that would be false. So just something to keep in mind, it's like a slight little tidbit there. You can do either one, and sometimes you want to use one over the other if you're not sure what kind of data you're looking at and things like that. If it might be a number, it might be stringified number, something like that. But typically, you probably are going to want to do the triple equals to really see, like, does this exactly equal? Or does it, versus, like, does it kind of equal this? But that's, again, just a kind of little side note. In this case, really all we're saying here is, if my grade is exactly 100, then print to the console a perfect score wins a prize. And the one thing I want to note here is that we don't have any other else or else if statements, right? We have just this single if statement. So if that condition does not evaluate to true, we're not going to do anything else. So the else keyword is not necessary, like the else if or the else keyword is not required to have. So you don't have to have a default case if your if condition doesn't return true. You can also do a bunch of if, else if statements and still not have a default else condition. We could just have the if my grade is less than 70, else if my grade is between 70 and 80. We could have that and not have this other default condition, right? Yeah, because it's just, it's just really for us, for our benefit to have an else if we want a default case. The only thing that, the only real rule here is that, you can't have like an else if there's no if statement, right? The if keyword is the one that tells JavaScript this is the start of my statement, right? Cool. So, if else are ways of handling control flow. But before we get into the next thing, actually, what happens now that we're done with this file? What happens to this execution context? Poof, right? Disappears. I'm still working on like an emerald style, like poof, pow, something like that. I need, I don't know. Help me out here. How you can keep the console there, it's fine. Alright. So yeah, so this execution context, poof, goes away. Our console is cleared, all of that good stuff. Well, let's say our console is cleared. That's slightly independent of the file being done, but in this case, we'll say we cleared our console as well, so that we can start a brand new, right? Okay. Did I go too far? No, okay. So yeah, so we stored data so that we could retrieve it later and run functionality on it, right? That's what we did. No! That's what we did here, right? We stored data, we stored my grade, and then we did stuff with my grade. Well, that's not the only thing that we can do. We can also do things like sum up numbers and find the average. In this case, that's what we're going to do. We're going to find the average of our grades, right? So now we're not talking about just one single grade, we're talking about multiple grades. This particular person, I suppose it's me, because it's my grades, has significantly improved since they started getting graded on whatever they're being graded on, right? So, yeah, so we have this built-in tool, right, this syntax, and this keyword, that's a for loop. Well, it's a for keyword, and that's going to tell JavaScript that we're going to loop over some data. So we talked about how arrays are kind of like a list, right? Lists of data. And we can access each item in a list, or certain items in a list, by looping over the elements in an array. And we can do that using a for loop. For loops are useful for things not just looping over arrays, they're good for looping in general. You can just loop to a particular number. You know, we could loop from 0 to 5 or from 10 to 20. You can do all kinds of things with for loops. We're going to talk about it tonight in the context of looking at specific elements, individual elements of an array. But just know that the for loop is something that you can do and use for things outside of arrays as well. But let's talk about what a for loop is. So for loop has kind of 3 to 4 main parts, right? Elements. So we'll see here, let's look at this keyword for, right? And then we have we have 3 different statements within that separated by semicolons, right? So the first thing we're going to do is we're going to initialize something. That first little block there before the first semicolon inside of our for loop is going to be an initialization statement, is the kind of technical term for it. And really that's typically where we're going to instantiate or declare some variable that we're going to use to run our loop. And in the case of arrays, a lot of times you'll see it as let I equal 0. So declare a variable in our memory that is the label I, and its value is going to start at 0. And we'll talk about that in a second. So we're going to initialize as initialization. Oh my. Words are hard. Okay, so the first thing is we have initialization in our for loop. Boop, boop, boop. Okay. Then we have this kind of second statement here, and that's our kind of check condition. So check if this is true. So similar to our if statement that we just looked at before, our for loop is going to use this kind of conditional statement to see if it should run the code block or not. So the second thing is going to be to check this. That's what we're going to do. And then our third bit we're going to actually hold off on for a second. Because as long as this check returns true, we're going to run into our code block. We're going to go into our code block and we're going to run the code block. So as long as that is true, we're going to do this, which is going to be our code block. And then once our code block runs, then we go back up to our for loop and we grab that last little bit there, which is going to be our incrementation statement. So it's going to be something, and we're going to actually run that statement. So we're going to say then for do this. Incrementation. And then we're going to go back up to 2. And we're going to check this again. So the grand scheme of a for loop is you're going to initialize something. You can choose to do that or not. That's an optional thing that you can do. Most times you're going to initialize something. That's going to be the first thing you do when you hit that for keyword. Then you're going to go to your check statement, right? Your conditional statement. And as long as that conditional statement returns true, you're going to run into your code block and you're going to run the code block. Then you're going to go back to your incrementation statement, that third little bit in your for loop syntax, and you're going to run whatever the incrementation is, and then you're going to check the condition again. And as long as that condition returns true, you're going to cycle through this pattern over and over and over again until that condition returns false. So that's the big keyword, or that's kind of the big takeaway here, right? Is this conditional statement, this check statement, that middle bit of the for loop is really important, right? We need to make sure that at some point that statement is going to return false. So has anybody run a for loop before? Created a for loop before? What happens if you don't? What happens if that statement never returns false? Well, what's one?
Some sort of error message.
Yeah, you hopefully get some sort of error message, right? Some sort of infinite loop or not even call stack exceeded, some sort of infinite loop will happen. And either you'll get an error, hopefully, if wherever you're running your code has some sort of check for that, will time out or something like that. Or if you run it in a browser, a lot of times what happens is your browser just crashes because it's constantly running the same thing over and over and over again with no end in sight. So it kind of just kills your browser. It overworks your browser until it finally crashes. Which is not fun, because then sometimes it even requires you to like restart your computer and stuff, so not great. So the check statement here is super important. Alright, so this is your template for a for loop and what happens in a for loop, right? But keeping this in mind, let's run through our code, right? So what's the first line in our code gonna tell us here? Susan? Oh, come on. This is the one we've done before, right? What happens when we see the keyword const? What's it going to tell us is the JavaScript engine. It's a variable, right? So what happens when we see const and we want to, where do we want to save that data?
Memory.
In memory, right? And what is my grades in this case?
50, 75, and 90.
That's going to be the value of it, but my grade is going to be the label, right? So we're going to create a space in memory for a variable, and its label is going to be my grade. And its value is going to be what?
Oh, 50, 75.
50, 75, 90 in what?
Hard brackets.
Yep, which is,
Array.
yeah, exactly. So it's going to be an array. with the values 50, 75, and 90, right? Yeah, see, you totally knew what was gonna happen. Yeah, so now we have my grade, value 50, 75, 90. What do we think is gonna happen next, Agnes?
Read the next line, which is next sum equals to, so it makes a level of sum and value 0.
Yeah, so we're gonna have a label sum with the value, the number 0. Now, does that look a little bit different, or just did those two lines look a little bit different, right? You saw that new keyword, right? Let.
Right?
Yeah, yeah. I see Susan over there. Yeah, what's that about? Nobody's telling us about that. Yeah. So, so let's talk about that for a second. Let's take a step back and talk about that for a second. So, const and let are two ways of declaring variables in JavaScript, because nothing says awesome like having two ways to do what seems like the same thing. But they are slightly different. So const is going to tell the JavaScript engine, okay, we're declaring a variable, it's still a variable, but this is a constant variable. The value, the type and value of this variable is not going to change. So my grades is always going to be an array, a list of data. Now I can change the values inside of this array, but I can't actually say ooh, I missed an S. That's important. Yeah. I can't say now, I couldn't have a third line there that said my grades equals 85, just the number 85. I couldn't even say my grades equals a whole new array with different values in it. Because it's not going to let me reassign the value here. So the const is telling the JavaScript engine, this is a constant variable. This variable is not going to change. Let is going to tell the JavaScript engine, okay, another variable, I'm declaring a variable, it's going to have a label and a value, but this variable, the value of this label might change at some point. So we're going to let it for now equal 0, but later we're going to let it be something else. Is kind of the way I like to think about that, right? Let is, I'm going to let this variable equal this thing for right now, or be assigned to this value, but it can be something else. Const, constantly my grades is going to be an array, right? Yeah, so just kind of different ways to think about it. There is a third way of declaring variables in JavaScript, which is the keyword var, which if you're doing any like older tutorials and things, it is pretty common to see the keyword var. That's kind of an older way of declaring variables. And var, in the sense of let versus const, is going to act more like a let. It's going to let you, reassign values. Both const and let have different scoping. We're not going to go too deep into that, or any deeper than just knowing that fact. Let and const have the same scoping, but var has much broader scoping. We're not going to go too deep into that right now. The point for tonight to keep in your head is that const and let are the two main ways now to declare variables, and you want to be mindful about using const only for constant variables that aren't going to change, and using let for things that you want to allow the values to be reassigned.
So you can't change the 50, 75, 90 at all?
Ah, you can.
Right.
So arrays are a little bit different. We'll talk about that in a second. You can change the elements inside of this array.
Right.
You can change like kind of the different, because it's a list, right? You should be able to change the items in the list, but you can't change it from being a list.
Okay.
And you can't change it to a different list, right? Let's say this is my grades, and this is a list of it's a list of our grades, right? We don't want to be able to reassign my grades to our grocery list, right? So this is always going to be the same list, but the elements and the items in that list can still change.
Can you have more elements?
Yep, you can add more, you can remove some. You could remove all of these so that all there is a list, an empty list,
Okay.
but it's always going to be this list.
Okay.
Yeah, awesome question, yeah. All right, so with the power of our knowledge now, on for loops in hand, let's take a swing at this for loop.
I have a question.
Yeah?
I didn't understand the, okay, why would I run a for loop? Like, why would I want to do that?
Ah, good question. So what we're going to do here, and we'll see, we're going to go through an actual, this is going to be an actual example of something you might want to do, right? So we have our grades, and we want to find the average of our grades. So what we want to do is we want to go through, and so the programmatic way of doing that, or a programmatic way of doing that, is going through each item in our grades, each grade in our list of grades, adding them all together, and then finding the average of them, right?
Okay, so when you say, could you repeat that process where you say initialization, then check this, then do this?
Yep, so we're going to go through this right now.
Okay.
You seem like you're ready to go through it right now. this feels like it was made to be, meant to be. So take us through it, right? So we're at our for loop now. We see JavaScript sees this for keyword, and each of those items in the parentheses there are each one of these statements: initialization, check, and do, the incrementation part. So let's walk through it, right? So the first thing is what? Initialization statement. That's going to be the first statement in there. So what's that going to tell JavaScript?
It says the variable I has a value of 0.
Yep, and where's that going to get stored?
Remember?
Yep, our global memory, right? So now we have a variable I, and its value is going to start, or its value is going to be assigned 0 for now, right? It's a let, so we're going to let it be 0 for right now. Then what's so initialization was let I equal 0. Great. So we did this step, right? Cool. Now what's our check going to be? Yep, so the check is going to be the second part of the statement in there, inside the parentheses, the second bit, so after the first semicolon, before the second semicolon. What's our check statement? Ah, yeah, so it's probably a little hard to see. It's I is less than my grades.length. So I is less than my grades.length. Cool. So let's talk about this statement right here, right? So we obviously know what I is. We just initialized it, right? Or not initialized, we just declared it. My grades.length. So another fun thing that you get when you use an array is this ability to add on this dot length, and it's going to be a property, because I talked about a little bit earlier that arrays are just objects under the hood, and we talked about when we have objects we can use that dot to find a property on that, the value of a property on that object. So arrays are always going to get this property of dot length, or this property of length. And it's just going to be how many items are in this list, right? So it's going to evaluate here. We're going to check, is the value of I less than the length of, or the number of items in my grades, the number of grades that we're looking at. So we're going to check this. So this is the first time we're running this. We just declared I as 0. So I is going to be what here? When JavaScript goes to read this, 0, right? And we're going to check, is I less than my grades.length? And we just talked about what dot length is going to return, right? So what is my grades.length?
50, 75, 90.
Ah, dot length. How many are in the
3.
list? Yep, 3, right? So is 0 less than 3?
Yes.
So it's going to return true, right? That's going to be true. So we're going to move on to our third step, which is do this. And what do we do when our check is true?
We continue, like run the code.
Yeah, we run the code. So what code are we going to run?
The I++.
Ah, are we going to run the I++?
Yeah.
No.
we're not. Because
Not
it's
yet.
True.
Right. Not yet. We are going to run it, but not yet. So when we get to our for loop, that last bit is going to be the last thing that we do. So it's kind of confusing. But we're using everything inside the parentheses are things we're going to need to do in this for loop. It just might not be the exact order in which we're going to do them, right? So the first thing we're going to do is that initialization, it's that first bit. Then we're going to check the check statement. Then as long as the check statement is true, we're going to run our code in our code block. So what's our code block going to be here? Code block is going to be between the curly braces, which are going to be these are curly braces here.
Oh, the sum equals sum plus grades.
Yep, so sum equals,
Sum plus grades.
sum plus
Grades. My grades.
my grades. And then we have this little bracket, right, with I. This bracket with I, right? So this line here is going to be, take our variable sum in memory, right? And now, what did we say this single equal sign does?
It assigns.
It assigns, right? So we can assume here that we're going to be reassigning the value of sum, right? And we're going to assign the value of sum, or reassign the value of sum to whatever the current sum is equal to, plus this my grades at I. So let's talk about that in a second. What is sum equal to right now?
0.
0, right? 0, okay. Plus my grades at I. And what is I?
0.
0. So what we're really saying is my grades at position 0. So this bracket notation here, so this is called bracket notation, is going to tell JavaScript, okay, go to memory, find this variable my grades, and it's going to assume now that it's an array, and it's going to look for the value of whatever is at position 0. So we talked a little bit earlier about how for arrays, again, really just objects under the hood, the keys for each of these items in the list are going to be an index. So they're going to be indexed, and anytime we're talking about an index in JavaScript, it's going to be 0 index, so it's going to start at 0 and go until, we're at the end of the list. So every item in the list, starting from the first item in the list, is going to have an index. So it's going to start at 0, 1, and 2, right? And so what we're saying here is go to memory, find the variable my grades, find the value of whatever is at position 0 or index 0, and then that's what this will be replaced with. So what is my grades at position 0? 50, right? Cool. So now we're going to assign the value of sum to current sum, which is 0 plus 50. So what are we going to reassign sum to? 50, right? Boop. Actually, I don't want to do that. I want to be very specific, right? What we're really doing here, we're not just adding a 5 in front of 0, right? We're actually removing this value and assigning it a whole new value of 50, right? Cool. So then, what's the final thing we're going to do for now in one iteration of this loop? What's the last thing we're going to do then?
Find the average.
Ah,
Oh, no.
this is loop, right?
Oh, loop. Then run the code. Go back and check this.
What's the only bit of that we haven't done yet? I++, exactly.
Yes.
So that's our incrementation. That's the other fundamental piece of this, right? We need to increment something so that we can get one step closer to this condition being false.
Oh.
Right? So the kind of goal here for a for loop is that we want to start at one place. We want to check if something is true. If it's true, then we want to run some code. And then we want to do something that's going to hopefully get us to a new place that's one step closer to being the end of our loop. And we just want to keep doing that and keep running this loop over and over and over again, in this case, going through each item in our grades list until we get to the end of the list, and then we can stop. Right? So we're going to I++, and this plus is just a shorthand for incrementing something by 1. So it's the same thing as I plus equals 1, which is still shorthand for I equals I plus 1. Right? Many fun ways of doing basically the same thing, but good to know, right? So we have this shorthand I plus plus, which is going to, what is I right now?
0,
0. What's I plus 1?
1.
Or 0 plus 1? 1, right? So we're going to reassign I to 1. Whew! Who's tired? Me too. Right? But we're not done yet, because then the final thing we do is we're going to, well, not the final thing necessarily, but kind of the last piece of doing our loop, right, is checking this statement again, right? So we did that one, so let's get rid of all this. I plus plus, cool, cool, cool. Now we're at our next iteration. So, checking. What is I right now?
1.
1. Checking if I is less than mygrades.length. What is mygrades.length?
3.
3. Is this still true?
Yes.
Yes. So what are we going to do? Sum, we're going to assign sum to, what is our current sum?
50.
50 plus, what is my grades at, I we said is 1 now, right? So what is my grades at position 1?
75.
75. Who wants to do that math for me? 125?
125.
Yes. Cool. Awesome. So, then we reassign sum to the value 125, right? And then what do we do? I plus plus. What is I right now?
1.
What is 1 plus 1? Who thought we were going to do basic math tonight? You guys paid good money for this. All right. Great. Did it. Done. Now what do?
We go back to check it.
We go back to check again, right? Whew. There we go. I is what?
2.
2. Is 2 less than
3.
3? Yes. What do we do?
125.
125 plus
90.
90, right? My grade's at position 2 now, right? So it's going to be the last 190. I picked really easy numbers here. What, 215?
215.
Yeah, cool, 250. Yeah, great, awesome. I haven't looked at these slides 150 times and I always forget that one. 215, great. Now, I plus plus, 2 plus 1,
3.
3. Now what do we do? Yeah, do it all over again. So, I is 3. Is 3 less than?
3? No.
No, it's not. Ha! Yes, we've run the marathon and now we've won. Great. So yeah. So what happens though?
It disappears.
Ah, do we have more to do?
Oh,
We have more to do though, right? So this is done, right? So we're done with our for loop, right? We've got, if we're going to be super specific about it, we came here, right? And then this, and we did all this, and now we're done. So now we're done here. So now we just keep moving on, right? Just move on. We're done. And what happens next? What's the next thing that we do? Suzanne?
Average.
Average, right? So what is the let telling JavaScript?
Some may change.
So the value of average may change, yep, right? But before that, just in general, we're going to declare that variable, right? Yep, so we have average, and what is going to be the value of average? Math. I will accept the answer, math. You don't have to go ahead and do that math. I will do it for us right now. Yeah, so we have sum, right? So average is going to be sum, which is what?
215.
215 divided by my grades dot length, which is what?
3.
3 times 100, right? Woohoo! All right. So let's do that math. I'm lazy, so it's going to be about 72%. So it's going to be 71.6666666. I'm going to personally just round that to 72 because.
Wait a minute. Why do you add yet it's a multiplication sign, or am I going blind?
Oh, you're right. I flipped it. My bad. Thank you. Good shout. Yep. So that's going to be average. Actually, I'm not going to rewrite that, which is going to come out to 0.7166 infinity. Right? Great. At some point, JavaScript will round that. There are ways to get this to round up or down. We're not going to go super deep into that. I should have picked numbers that come out even. I'm going to update these slides because I don't want to have to do this every time. But yeah, so it's going to come out to about 72%, right? But, or, 70.771, 72 or so. But yeah, so we did it. Now what? Poof! Yes, poof. See, you do poof better than I do. It doesn't work for me. But yeah, poof. We're done with the file. Now all of this work goes away. Bye. It's been real. It's been fun. Awesome. Great. So,
I have a question.
yeah.
So, I'm confused where you put sum, the let sum equals line.
Mm-hmm.
Because sometimes I see it after the for loop is declared.
What do you mean? Give me an example.
So right now you have let sum equals 0
Mhm.
as the second line,
Mm-hmm.
and I've sometimes seen it as the line above where sum equals sum plus migrants.
So inside that code block?
Yeah.
Good question. So the question basically being, what would happen if we had, so we have our for let I equals 0, I is less than my grades dot length, I plus plus, great. What would happen if we had let sum equals 0, sum equals sum plus my grades at I? Okay, basically that, right?
Yeah.
So, what happens every time we go back and restart our for loop?
We replace the value of sum.
Yes. So this data kind of goes away at each iteration, right?
Okay.
So yeah. So we'd be reassigning sum to 0 every time, right? Because we rerun all of this code every time. So if we have that inside of our for loop, we're going to reassign it to 0. So in the end, it's just going to be 90. Right.
Okay.
Because we're first assigning it to 0, and then we're setting, and then we're reassigning it again. Yeah.
So you don't ever want to do that.
Sometimes you might. Sometimes you might want to get a sum of something and then check it in some way. So sometimes you might want to declare variables inside the for loop. You might want to do that. In this particular case, you would not want to do that because you want to find the sum of all the things. But yeah, there are definitely cases where you could want to declare a variable inside of the loop. For example, if you were doing something like, let's say, finding the kind of if you were doing some kind of math and finding the like largest, the number that produces like the largest multiple or something like that. So if you did like, or the largest square, I don't know, something like that.
Or maybe like if you added a conditional in there? And
Yeah, if you had some
checking
kind
or
of
something.
conditional, things like that, you'll actually get a hand in some of that in the challenges, so you'll get practice there. But yeah, there are occasions where you'd want to put a variable inside the for loop that you want to reset every time, but just not in this case.
We have challenges?
Oh yeah, because guess what time it is? Pair time. Cool. So yeah, so you guys are gonna pair up. In this case,
Just.
you guys are gonna work together. So yeah, so we're gonna pair up. You don't have to do that. For anybody working online, you guys should have separate, not CSX challenges. You'll have CS bin challenges. You guys should have gotten an email about that. So disregard this slide. Cool. Great. So yeah, so you guys are gonna go to CSX. You'll be on one computer. So you know. Yeah, some guys just all kind of squished together. So, pair programming. So let's go through what we're going to do when we talk about pairing, right? It's time to pair up and pair program, or try program in the case here. Yeah, so pair programming, for anyone that hasn't done it before, it is really awesome. And has a lot of benefits, right? We talked in the very, very beginning, right, about those core capacities that we look for at Codesmith, or that are really important in general for being a good engineer. Technical communication and analytical problem solving, right? And pair programming is an awesome way to get practice at both of those things. Especially the technical communication part, right? Because it's one thing to sit at home and look at challenges online and go through things on your own and get stuff working, and that's great, and that's awesome, and that is a really great way to learn. But when you have to explain how to do that to somebody else, that's where you really start solidifying that knowledge, right? Because you can find flaws in your logic maybe, or maybe that other person has a better way of doing it that you never thought of before. You can always, there's a ton of benefits to it. But two of the main ones, right, are that when you work alone, you can sometimes fall into one or both of these traps, right? Where you come across a problem and you've never heard it before, right? So there's some words in there that you don't really understand, arrays or objects or something like that, or use a for loop to do something you don't really know what a for loop is. So you go to Google or MDN or something like that, and you look up, what is an array in JavaScript, and you go there and you find, 15 other words that you've never heard before, and you start looking those up, and now an hour's passed, and somehow you're on YouTube watching cats. You're like, I don't know how I got here, but I haven't written any code. I can tell you all the definitions of all the data types in all of JavaScript and all of Python, because somehow, but I haven't written any code, and I still don't know how to do this thing that I was asked to do. So you get into this kind of research mode, and that kind of takes you down rabbit holes that you don't necessarily need to go down for that specific problem. The other thing that can happen, right, is you see a problem, you're not sure how to do it, so you go to something like Stack Overflow or somewhere where you start writing some code, but it's not quite working, you can't get it to work, so you go and you kind of Stack Overflow, like how would I do this? What's the best way to do it? Someone else has done it before, great, you copy their code, you paste it in, you're like, awesome, cool, that works. Then you get a little further into the problem, and you're like, oh no, I don't know how to do this other thing, and you go and you do the same thing, you paste something in, and you're like, great. But now these two things don't work together, and I need them to work together. So you write a Stack Overflow post, and you say, how do I get these things to work together? And somebody tweaks your code and gives it back to you and says, now it works. You copy it, you paste it, it works, everything is great, and you say, I'm done. Awesome, I can move on, I beat that challenge, right? I nailed it. But if anybody asked you, like, why does that work, or how does that work, you'd be like, it works. Why are you asking me this? Like, it works, right? So yeah, so that can be a problem too, right? Where you feel accomplished because you feel you've done something, but if you don't really understand how it works or how to explain it to somebody else, did you really learn that much? Nah, probably So pair programming is awesome for both of those things, right? You have a partner there to pull you out of that kind of research mode and say, hey, let's just start trying stuff, right? We're getting maybe into a rabbit hole of we're not even working in Python and now we're looking at like how to do list comprehension. We don't need to do that, right? So let's pull back and let's start actually coding stuff. And conversely, you guys might use Stack Overflow or these other resources to find answers to things, but you have a partner there to say, okay, let's go back and really like dig into why does this work, and let's go back over it. I'm not really sure how or why you wrote what you did or how it works, so can we go over and explain it, right? So that's what we're going to do tonight, right? You guys are going to pair up and you're going to work through these challenges together. There are two main roles for how we're going to pair program here at Codesmith. We're going to take a driver navigator role, or well, there's a driver role and a navigator role. In the case of the three, there's going to be an observer. So you guys will switch these roles as you go through them. The observer can participate in the kind of general discussion in the beginning. So you're going to start out, you're all going to read the problem together, you're all going to make sure that you're on the same page about what the problem is asking you to do. And you can maybe talk about some strategies, or at least all get on the same page with, you know, if somebody's never heard of a function declaration before, things like that, you guys can all get on the same page about that. And then you're going to want to break out into these roles. So somebody's going to be the observer, they're going to kind of then take a back seat and not really talk at all, they're just kind of going to observe the other two. Then there's going to be the driver and the navigator. So the navigator's job is to not touch the keyboard at all, they're not going to write any code, they're not even going to talk in code, they're not going to talk in any of those keywords that we talked about, const, let, for, you know, any of that stuff, right? The navigator is really going to navigate through the problem in plain English, right? If it is, you know, if we're looking at this example here, right? We want to average our grades. We're gonna get an array of grades and we're going to somehow find the average of them, right? So the navigator would say, okay, so all right, we're gonna need to store our grades in memory, and then we're going to need to somehow loop over the list of grades and sum up each grade as we go through. So we'll probably need something in memory to be able to hold the sum. And then after we've got the sum of everything, we're going to want to average it. And we're going to want to find the average and do some math to find the average, right? That's what the navigator's going to do. They're going to solve the problem in plain English, and it's the driver's role to interpret that solution into code. Right, so they're going to hear the navigator say something like, okay, we're going to need to store our grades in memory, and they're going to say, okay, const my grades equals, you know, 50, 75, 90. You know, you can think about those things of like, should I use a const versus a let? That's a driver thing, right? That's not a navigator thing. And then, yeah, then they're going to write the for loop syntax and all that stuff. And then you guys are going to run it, right? And you're going to see it work, or potentially see it not work. And the key here is that you're there to help each other, but you don't want to overpower each other, right? So if you're the driver in this situation, and you're listening to the navigator, and you can kind of spot a flaw in their logic, let them run through it and still code out what their solution is to it, and maybe they'll realize as they see you coding it out, or maybe as they're talking through it, that there might be a flaw there. So let them kind of naturally come to that. But, you know, if it's, you know, 5 minutes go by and they're not seeing the problem, then you guys can, that's what you're there for, right? You're there to pull them out of the hell of why isn't it working, right? And conversely, right, if you're the navigator and you see the driver making a syntax error, right? Maybe they're missing maybe they used a regular colon or a comma instead of a semicolon in their for loop syntax, or they missed a bracket, or they used a const instead of a let. Let them run through that, let them run their code, let them see the bug, the error, whatever it is, and give them some space to figure that out on their own. But yeah, you're there to bring them out if you know, they get down a rabbit hole, right? So with all of that in mind, go forth and pair program. Yay!
Do we need to sign up to the website?
Oh yeah, so csx.codesmith.io, yep, and if you go up to the top, I mean you can click it right there as well. If you don't have an account, just create one. Yeah, cool. And then you guys will do you'll start at the pre-course. And I'm gonna have some of our residents this. Because I've got you running for a few minutes, but I'll be back to do the second part of the lecture very shortly.
Yeah, she said to just go to the pre-course. This one? Yeah. So then first challenge. Okay, this one. Also.
I'm Clarice.
And I'm Mia.
Okay. Oh, we need to solve this.
You ladies got it. Definitely help you.
We just pulled up the page.
Oh,
So.
okay.
It's okay to read it out loud.
Sure, sure. So, wait, so I'll be the observer, so one of you, I
You
guess
have
you're
the
gonna
most
be.
experience.
You better be the driver. You better here.
No, you're at the computer, so you get to be the driver.
Okay, you can just correct me.
No,
Okay. You want to start?
no, go for it. You're the driver and Agnes can be the navigator.
Oh my god.
You can do my voice.
Sure, yeah.
Can you see?
Yeah.
Okay, so which one are we doing?
Declare constant name, last name. Assign a value for last name.
So to
What's-
uncomment, you just take out those two slashes.
Oh. Like this?
Yeah. And then if you want to check, you can grab the code.
Syntax error. Why do I need extra?
So, look at the line that you uncommented. Was that the line that you wanted to uncomment?
Actually,
So read line 10 again. What is the direction say on line 10?
okay, uncomment constant statement on line 10 and run your code. You should see.
Because I think
Read the directions.
Oh,
yeah.
oh, got
Yeah.
it.
So you're going to want to comment out on line 10 again, because then that's what's giving you the syntax error.
Last name is not defined.
So, kind of.
Oh,
Go back to the.
it's not fine.
But Agnes is gonna navigate, right?
Yes.
no, I'm
And then-
trying to read them. I'm trying to see why it will work.
You should see change
Uncomment.
using your first name.
So let's talk this out, like line
Yeah.
by line, right? So the challenge instructions, it says, first thing we want to do, below line 6, declare a constant name, last name. Look at how they wrote last name,
Oh yes.
and then is reassign the value.
Do you call it camel?
Yes,
Camel
camel
case.
casing. So in JavaScript, whenever last name, it's two words, right? So when you're gonna be combining two words, you're always gonna camel case, meaning capitalize the second. Yeah, exactly. Which is fine.
Okay.
So yeah, JavaScript is case sensitive. That's why I was saying last name is not defined because it has to be spelled exactly the same. Yeah. Otherwise, it'll give you these weird errors.
Now, but then it said, go ahead.
Oh, and then the next paragraph, it
Mhm.
says, now go back to line 1. So we've got to go back up to line 1 and modify the value of the first name to be your first name.
Okay.
And then,
A common console line or plan, which is Jenny replacing your social pronoun.
We don't have this.
Really good technical communication as well. Yeah, that was really good how you problem solved through that. Yeah.
Good navigating.
I can do pre-course
You can. Yeah. Problem solving is good.
Thank you. Okay, now we have to go
We
to
have
the
more?
next one. Yeah.
Oh.
So there goes next.
Oh.
Would you like to do this one?
Oh, okay, I'll try.
So then you're gonna help her, right?
Oh, maybe you'll help me.
Go read.
No, sorry. If it wants to, but right now it doesn't
I
want
guess
us
it
to.
doesn't want us to do it.
It's like, oh, you've done enough, go
Yeah.
celebrate.
Break for today.
Yeah, that's good for today. You'll come back next time.
I'm a big fan of baby stuff.
Yeah. It's
I
really
feel like everyone else is
hard.
doing this from board.
Our work is done. We should go home.
Classes over.
Classes
Our
ended.
work is done.
You know, when she explains it, you kind of see it, like it makes sense.
Yes, yeah.
But I was watching the tutorials on Code Academy. They just put the instructions here,
It might be stuff.
and you're supposed to do that stuff, but you don't even know what they mean.
Well, Sam's really good at explaining.
Yeah.
all of
Thank
it,
you.
So it helps.
Take it away.
Oh,
Woohoo!
I was hoping.
We know that.
Okay, so it says you can update variables that you declare with let and var. What happens if you try to reassign the value over const? Well, what happens is it's constant, so you cannot reassign. Right? That's
Yes.
what I remember.
Yeah, right,
Yeah.
yeah.
Okay, so it says, look at the examples below and notice how the value assigned to the variable last name changes. So we have let last name, Snow. Then you put it on the console, then last name, Focus. What, how do, Folks, I think. Okay, so yeah, when you use let, it lets you change. Okay, so challenge. In the code editor, reassign the variable first name to a new name on line 4. So we have this. So I go to last name. Let. First name. Oh, another one? I'll use one. Nice. And then, oh, check the answer, okay. Now, what does it say? Syntax and the first name has already been declared.
Let's see number 1 and number 4.
Yeah. Okay, let me read the challenge again. In the code editor, reassign the variable first name to a new name. Oh, the variable, not the value. English. So variable first name to a new name on line 4.
What do you ladies think?
What do you think?
So, I think if we look at, it's not so much that I need to change the name of the variable, right?
Yeah.
But the value of the variable. So, I think first name, what you had with first name equal Agnes. But if we look at the example here,
Yeah.
the first time last name is declared, there's let in front
Yeah.
of it, right?
Mm-hmm.
But the second time, it's just last name. There isn't the let in front of it.
Oh, like here. Oh, because. Okay, because here it's saying let it be this, but this time we are changing it to this.
Right.
Oh, yeah.
Do you ladies know why that happens?
And is it that the first time you declare it, the let is what tells JavaScript that we're creating a new variable,
Right.
and then you're just changing it?
Exactly, yeah, because you've already declared it by the lesson. Yeah, so on
You don't
line 4, yeah, you don't
need
need to.
to select.
Right, because do you guys know how JavaScript goes line by line?
Mhm.
So I went through line 1 first and said, okay, there is a variable called first name, and that's Jenny. It's already there. On line 4, what you had initially,
Yes.
the first name,
Yeah.
all you have, everything was right. All you have to do
is remove the light.
yes.
Oh, because
Yeah.
it already knows that we are dealing with the.
Yeah, you had it right the first time. Yeah, you copied it.
And also like on the memory of the computer, like you have a hard drive, right? So like it's all blocks. So what happens when you declare a variable is that, okay, I want to declare a first name variable and I want to use all of these blocks. So right now I declare it Jenny, and then say if you want to redeclare the first name variable to your name, the JavaScript will say, I will look for the Jenny, the last first name variable, and instead of Jenny, I will replace it to something else. So like variables are just like blocks inside our hard drive. So like those are just like memories, references to this memory.
So, so you're good.
Yeah.
Run it.
Just
Okay, so that's it?
yeah,
Nothing more.
just let me see. Okay, so when it says right here, what happens when you try the value of a const? Do you guys know what value is inside of here? Like what points to value?
Yes. Jenny is a value for this fact.
Right. So anything usually when as after the equal sign, it's declared as the value of that. So let's make sure.
Oh, finished. Perfect.
Yeah, actually, no, they need to remove the console
Oh, they
log.
want us
Yeah,
this way.
because
Oh,
you
so
need
it's
a.
handwritten. it.
So do you guys know what console log means? So console log basically means like write whatever I was typing here inside of my command line. So yeah, so once you remove those back,
Like it's your log.
yeah, it's your log. It's telling you what you're writing almost.
Okay, so the things with the instructions, it will give us what, like the response down here,
Yeah.
what we see.
So if we run that again,
Sorry.
So it's looking for what's inside
Agnes.
the variable.
Sorry.
Perfect. Yeah. So
It says client.
Oh,
so console log is saying type this out, hello, and then the first name, look for the first name variable and all the way out to
yeah.
Agnes.
Okay. So this is JavaScript doing this, then this is what we see on the console. Like let's say if you run your website, this is what will appear on the website.
To a certain extent, to a certain extent, console log is kind of used more for test cases like this. When you build websites, it's kind of formatted differently, but it is the same idea.
Oh.
Yeah.
So there you go.
Very interesting to see you guys navigate here.
alright. So, I'm just gonna type whatever you guys tell me to type.
I know, I was also pressing that side, I'm
No, I
not
know,
used to this
too.
side.
Like if it's
No.
Oh,
press
the
the
side, yeah. I was also
Press
going
on the
to
left.
my
There we
right.
go. Okay. There we go. Okay.
Oh, we even have a mouse that we didn't use it.
Oh, I don't know. I'm so used to like doing that. Okay. So what do I do?
Well, you read us the instructions.
So strings are data type in JavaScript. In short, they're bits of text written inside of quotation marks. You can use either single quotes, double quotes, or backticks as quotation marks to wrap a string, as long as the opening and closing symbols match. They are particularly useful for any data or value that can be represented as plain text. Uncomment the text on lines 3 through 5 to see examples of strings.
I'll just press
Took
on
that
that.
off. There we go. There. And then so if we grab that, I am going to learn this. There we go. I have a Chromebook, so
Oh, okay.
it's all
different.
yeah. Okay, so it shows what the strings are. So now the challenge is to declare a variable my string whose value is a string. So,
Do we need a line on which to declare any?
so
I'm thinking we could use const.
okay.
And the variable is my string. So const my string equals string in parts.
Like that.
Yeah.
Okay.
You agree?
Mhm.
We
I
agree.
like
Oh
all
no, you're
that.
gonna do that.
I don't know how it's called.
Oh, the semicolon.
Semicolon.
After.
Like that. Okay. And then
There you go.
uncomment it.
And run.
And then run it. Woohoo!
Yeah.
And look at how we're all like so smart. We're like,
Work is very important.
yay! And now we're back to you.
Yes, Susan.
I'll try. Okay, this exercise will explore string concatenation. String concatenation is a joining strings together. If a word is an example of previous section, which uses a class project. Okay. Challenge. Use string to join the pre-provided strings for a second. Assign as results in the variable statement. Value should block out. Okay. Console. Challenge. Use
It's okay.
as a function to join first. Should I do,
Before you guys begin, do you guys know what string concatenation is? Like maybe you guys all have a general understanding of what it is before you guys,
No, I haven't seen this.
maybe you guys should talk it out to each other if someone does know what it is.
So it's just the joining of different strings. So that's pretty much what it is, right? Yeah.
and then do we assign like a const
So
name and then
when you're
Well,
Right.
so like the example I gave you would be like, so this string hi, right? And then we add whatever the variable is, first name, right?
Okay.
Because hi, like for example, you would always have hi, but first name is what changes, right?
Mhm.
Because sometimes it's Agnes, sometimes it's Susan, sometimes it's Petula. So the concatenation makes it so that you don't have to type hi every single time.
okay. So when you're joining, it says three provided strings, first, second, and third.
so do we do
Hello.
Hi.
Hello. the world, but let's hope. So we're gonna reconvene so that we can go through the rest of the lecture.
Your job is.
Yay! And then, should you so choose, you may get back to pair programming. Thank you guys. Spoilers. All right.
No more.
Good? Good. Sweet. Awesome. Where'd you guys get to?
3, I think.
Nice.
Oh no, 4, because 1,
Yeah.
2, 3,
Oh, yeah,
4.
4. Yeah, we're done.
We have 4.
Nice. Awesome. Sweet. So you guys all got a chance to play all the different roles? Sweet. Nice, nice. Awesome. Well, you guys can continue pairing after this if you want. I know it's getting a little late because we started a little bit late. Sorry about that. So, one thing we haven't talked about yet, right, is we're up until now, right, we've had these files, and we've gone through line by line, we've just done this stuff, and then we go away, right? And in this example in particular, right, where we went through and we averaged our grades, that was a lot of functionality that we went through, right, to go through each iteration, each line. It's not that much code, but it's still like a decent amount of typing code, right? What if we wanted to average my friend's grades? What would we have to do in this same file to now average my friend's grades? We'd have to probably like create a new variable, like my friend's grades, and then we'd probably have to rewrite this for loop, right? But it would be almost the same, right? Because, you know, we have our for loop, we're still going to loop through an array, we're still going to sum things up, and then we're still going to average them, right? In the end. So, we don't want to have to write out all that code every time, right? So we can wrap our functionality, we can wrap that for loop and also the sum and all of this other stuff inside a label, and then we can save that label the same way that we do variables in memory. We can save functionality or instructions for functionality in memory as well. And we can do that using the function keyword. So a function is a label that we're going to assign a value which is going to be functionality that we can run and reuse over and over and over again. So what we're looking at here in this example is creating a function to average my grades. If I want to be able to average my grades more than once, for some reason, I can wrap the exact same functionality we had here in a function so that I can do it more than once without having to repeat my code. Right? And there's this kind of principle in JavaScript and programming in general, keeping your code dry. And that just means don't repeat yourself. Right? So if there's something that you're repeating and doing over and over again, if, for example, I want to average my grades more than once, I'm repeating myself if I just write that code to do it twice, right? So instead, I wrap my functionality in a keyword functions, and then in order to actually invoke or call or use that functionality, I just add parentheses to the end of that label that I give it, right? So for example here, this function, average my grades, right? When JavaScript engine sees that, it's going to create in memory a space for that label, average my grades. And what's actually going to be stored in memory is the whole function definition. So I'm not going to write out all of that, but I will store it as that little fun symbol right there. So it's going to take all of this code here, this whole code block from the beginning the beginning curly brace after the parentheses there to the end, the closing curly brace, at the end there, and it's going to save all of that code in memory, and then it's going to move on. So it's not going to run that code yet. When JavaScript sees that function keyword, it's saying, I'm declaring this function the same way I'm declaring a variable. I'm assigning it a value, a label and a value, but I'm not actually running this code yet. So I'm going to just skip those lines. We talked about how JavaScript is single-threaded. It goes line by line. The inner part of that code block for that function definition doesn't necessarily count as a line-by-line quite yet. The fun comes into play when we get to the next line that we're going to run, which is that const output, right? So again, same thing we're used to, right? With const blank, right? Telling JavaScript we're going to declare a variable in memory called output. And now, though, we're going to assign it to something a little bit different. So now we have this variable name, right? Average my grades, but we have these parentheses at the end. And when JavaScript sees those parentheses at the end, it's telling JavaScript, this is something that I can invoke. This is functionality that I can call or run or invoke. So what I'm going to do is I'm going to go into memory. I'm going to look for average my grades, and I'm going to try to run whatever functionality is there with those parentheses, right? So if, for whatever reason, average my grades was not a function definition, was not some kind of functionality that we could run, we would get some sort of error like average my grades is not a function. But we're lucky, because in this case, average my grades is a function. So one thing that's a little bit different when we assign the value of a variable to the output of a function is it has to actually run that functionality before it can actually assign any value here, right? So it does give that value a placeholder. It does give that label a placeholder while it's running that functionality, and it's going to give it this placeholder of undefined. So this variable has been declared. It's got space in memory, but its value is currently undefined. And now here's where it gets really fun. We're in our JavaScript file, right? We have our global execution context. Now, when we invoke a function, when we call or run or invoke a function, when we see these parentheses, we get something really special. We get a new execution context inside of our existing global execution context. So we now get a little baby execution context here. So we run average my grades. Whoop. And we're going to say that this is a local execution context. And when we get a local execution context or a new execution context, we also get along with it a little local memory. So this is all still inside of this global execution context that's running. But now our thread, instead of continuing down here into the rest of our code, in our global file, we're going to move our thread inside of our function definition. So now, this is where we're actually going to start running this code line by line. So JavaScript starts up here, we hit function definition, average my grades, and then we continue on and move past the function definition because that's all saved in memory. We hit new output, average my grades is a function, an invocation of a function, so we get a new local execution context, and our thread of execution, our little thread, moves inside of our function definition to start running that functionality. With me so far? Cool. Awesome. Now, one thing that goes along with this that we can bring up here is that anytime we invoke a function, it gets added to our call stack. So there's this kind of, so we have this console bit that's kind of out of our realm of execution context and development, but we also have a call stack, and it's pretty aptly named because it's a stack and it's what we call, it's got philo. So it's first, first in, last out. That is confusing to look at, but basically, I'm just gonna get rid of that right now. First in, last out. So the first thing that goes into or onto our call stack is the last thing that comes off our call stack. And when we talk about our call stack, when we open up our global execution context, our first, when we start running our file, we actually have something on the call stack that that's gonna look like global. So that's why we see this like global execution context, global memory, that's our whole file running. That's always the first thing that gets what we call pushed on, and it's the last thing that gets popped off. When we invoke another function inside of our global execution context, that invocation gets pushed on to our call stack. So right now where we're at is we have invoked our function. Well, we've declared our variable output. It's currently undefined because we're waiting for an output from invoking our function. Our function's been invoked, it's been pushed onto our call stack, and we've got our new local execution context. And now JavaScript is going to start running inside of our local execution context. It's going to start running the functionality in average my grades. And the first line that it's going to hit is this line that we're very used to by this point, right? Const my grades equals this array of values 50, 75, and 90. Now, where do we think we're going to store that variable and its value, the label and value? Local memory, right? Because we're now in our local execution context, we've hit const my grades equals right? And so when we see this line, it's going to say, okay, create space in memory, create space in our local memory for a variable called my grades, and assign it the value of an array 50, 75, and 90, and I'm going to be super nice, maybe nice, I don't know, let me know if you want me to do this, but we're not going to go through this for loop line by line again, and we're not going to go through all of this quite line by line again. It's getting late, we don't want to do that. I encourage you though, if you're still concerned about the for loop or still struggling with it a little bit, go through each of those things. What I am going to do though is we're going to go through just what the steps would be, right? We don't have to go through it the whole iteration, but what is the first thing? So then we have our sum here, right, is 0. Let's get rid of this. Okay, now we're hitting this for loop. So when we hit our for loop, what's the first thing that we do the first time we hit this for loop?
Initialize it to 0.
Initialization, right? And that's going to be I equals 0, right? What's the second thing? What's the kind of headline for what's the second thing that we do?
Check.
Check, right? Yep. Check this. And what are we checking?
If I is equal to 0.
I is equal to 0?
Oh, sorry. I is less than my grades dot length.
Yep, I is less than my grades dot length. And as long as that's true, what are we going to do? What's next?
Plus my grades at the position of L.
Yeah, we're going to do this, right? And that's going to be sum equals sum
That's my grades
I. And what's 4?
So you check it, check the condition again.
What's 4?
Increment.
Yeah, there it is.
Increment.
Do this incrementation,
Oh, I have one.
right? I plus plus. And then what do we do?
Then we check
Then we check again, right? And then we go back up here, right? So yeah, so exactly. We're gonna initialize, we only do that one time, then we move on, we check this, provided that's true, we do the stuff in the code block, and then after that, we do that last statement there, the incrementation, and then we check again, and the cycle continues and continues, until we eventually get 0, 50, 125, 215, and then average comes out to, let's just round it to 0.72. Let's just say we've added some code there to make the math 0.72. And then what happens? What happens on that last line? We actually don't even save this in our memory. I lied. I changed that. We do this math, we get 0.72, and what do we do with this 0.72?
Then we can define the output.
We can define the output, and why can we define the output? Is there a new keyword there that we're seeing? Return, right? So this is something special in JavaScript. Well, it's something special, right? It's a special keyword. It's got a lot of fun things. So return is saying, let's return this out of this function, right? So that's how we can return this 0.72 out of the function, and now we can set our output. It is now defined as 0.72, because it was the returned value out of this function. And so, now we're done with this function. What do we think happens now? What goes poof? Yes, that is correct. What goes poof?
The local execution.
Yeah, exactly right. This local execution context goes poof, gets out of there. It's all done, goes away. We still have this returned value because it was returned out of that execution context. That's the power of that return keyword, is that even though this execution context has gone away, it doesn't exist anymore, we have no access to this local memory anymore, we've returned something out of that function, so now we have this data that we can store up here in our global memory. Awesome, right? What else do we think happens? Popped off the call stack, right? So this is gonna pop off here, pop. So this goes away, and I'm even gonna just delete all this, right? It's pushed on, popped off, it's like it never happened. Where does our thread of execution go? Back to the global, right? Because now we're first in, last out, so we're back in our global. So our thread goes back to our global, and what do we see next? New output, right? So we're going to do, not the color I want, we're going to do new output. What is it going to be defined as at first?
Oh.
Before we have the output of that function, what is the placeholder that will be here?
Undefined.
Undefined, right? And so what happens now that we've hit this invocation of a function? What happens when we see a function invocation? A new execution context, yep. New execution context. New local memory, not EM. Cool. What else happens?
Push.
Yep, pushed onto our call stack, right? Now, is there anything in our local memory?
No.
No, right? Because this is a brand new execution context. New color, new execution context, right? So we don't have any access to those old variables that we had declared in our blue execution context. That one's gone. It's like it never even happened, right? So when we run this function again, the output is going to be the same thing that it was the first time because we're using the same the same values, right? So again, output is going to be 0.72, right? This is no longer going to be undefined. It's going to be 0.72. And then this execution context goes poof, or goes, there we go. It's so much lighter, nice, it's great. I shouldn't have erased that because it should just be 0.72, right? Popped off the call stack,
Yeah.
boop, boop, boop. This is 0.72, right? And we go back to our global execution context. And what happens in our global execution context? We're done. So what happens? Poof. I just want to be done with all the execution context because now I want to hear that. So yeah, so poof. But now what's... Everything is horrible. There we go. All right. So now what also happens, because now we have a fun new thing, so not only do we, everything in our execution context goes away, but what else happens? Our call stack, right? Global is popped off our call stack, and now we've got nothing, and we are sad. Or we go to sleep, because we're the JavaScript engine, so we go to sleep now, right? It's nap time. Cool. So, that was great. That was fun. But there's one more piece that we want to talk about, which is that averaging my grades is a ridiculous function. Why would we ever want to do this more than once for this exact set of data, right? Well, we want to create functions that are reusable in a broader context, right? So in the sense that we wanted to average my grades, well that's cool, but what if we want to average anybody's grades, right? So let's make a function that will average any grades. It will take in a variable, perhaps, that we can use in order to make this functionality reusable, and also, but reusable in a realistic way, right? Reusable in a way that we can average anybody's grades. And so the last bit of this that I want to talk about is inside the parentheses now, when we look at our function definition, we now have some stuff inside those parentheses, right? And what does that look like, right? What does that grades look like? I mean, it kind of looks like a variable, right?
Yeah.
It a little bit looks like a variable, right? So the terminology that I want to talk about here is that a lot of times you will hear the terms parameters and arguments used interchangeably, but they do have slightly different meanings, right? So grades here, the word grades, when we define our function, the word grades is a parameter. And the parameter is what we're going to use in our function definition to reference data that is variable, that will change or could change every time we run this function, right? But it's a placeholder, it's the label by which we will reference our data, right? So parameter, in the sense of a function, is the label by which we will reference our data. When we invoke our function, we see that there are now two different arrays there, right? With two different sets of grades, or two different lists of grades, right? So when we invoke our function and we actually pass in the value for grades, that's our argument. Those are our arguments, because you can have multiple arguments there as well. We could have commas separating multiple arguments there. So we could have grades, and then maybe we have another parameter that's name for, these are the grades for Sam. And then we could maybe print something to our console before we return out of our execution context and say, like, Sam's average is whatever. Matula's average is whatever, right? So yeah, so we can have multiple parameters being the label by which we will reference our data, and arguments being the value for which that label will be replaced, or the value for which we'll assign that label when we get into our local execution context. So the biggest difference, or the biggest difference is when we actually invoke this function, average any grades. Let's pretend we've gotten that far, right? We're in global, and we push on average any grades, right? New execution context. very average any grades. Now we see that we have some stuff in here, right? The first thing that we're going to do, instead of starting with the first line inside the code block, we have to handle any parameters or arguments that we've been passed. And all that that really means is that we're going to assign a place in memory for them. We're going to open up space in memory. We're going to define a variable called grades. And we're going to assign it the value of whatever our argument was that was passed in, right? So 50, 75, 90, right? This looks almost exactly like what we did before, where we had that hard-coded my grades there. But now instead we just have whatever grades, whoever's grades they are, now sitting in our local memory. So parameters get stored in our local memory the same way other variables that we're declaring inside of our local execution context get declared. And then it's really the same thing happening there, right? We're going to return out, in this case, we're going to return out the exact same 0.72. The real difference comes in then when we get to new output, where we're actually going to return a different value. And now we will have two different variables in our global memory with different averages that use the same set of instructions, right? The same functionality, same set of instructions to come up with those answers or to come up with those values, which is pretty cool and pretty powerful. And we can see like how this might be useful in huge applications or in general, right? Where we want to not have to repeat ourselves over and over and over. If we were making an application for teachers, right, to be able to average their students' grades, they could use this function over and over and over again to put in many different students' grades. We can even go as far as to say, let's say creating a for loop outside of this that goes through an array of students' grades, of different students' grades, and passes each one of those into that function. So that's getting a little ahead of ourselves. That's going into some things that you could learn in hard parts. You guys come to callbacks or closures hard parts. Really any of those, you get a little bit into that. But yeah, callbacks and things like that. So super fun, super powerful. The last thing I want to talk about is this console log versus return. I'm going to come back to that a little bit. So console, we said, right, is for developers. So if we had this function, looks very similar to this function, but instead of returning we are console logging, what do we think we would see? What would output be defined as once that function runs? So it's got that placeholder undefined until it gets whatever the return value of average any grades is, or whatever the output of average any grades is. What's the output of average any grades if this is our function?
72.
Is it? Are we actually outputting anything? Are we actually returning anything out of this function? Nope. So you don't have to use that return keyword in your function. You don't have to, because once it gets to the end of the code block, it will stop running that function. But the return keyword, one, tells JavaScript, I am returning out of this function. I am done with this execution context. So if we have the return keyword and we have stuff under the return keyword, so if we had return here and then underneath that we had console.log, my name is Sam, it would not run that console log because return tells JavaScript, I'm done with this I'm done with this execution context, break me out of here, clear this out. Pop me off the call stack, do whatever you need to do, I'm done. So that's one benefit of the return keyword. The other, well, benefit, one thing about the return keyword. The other thing is that you can use the return keyword to tell JavaScript, I want to return some value out of this function for the broader execution context to have access to. Console log, just for developers, right? Just for us, just for people to look at. Not for computers, just for people, right? It's printing something to let a developer or some other person read it. So the return keyword is for computers, is for the JavaScript engine to be able to evaluate or utilize a value out of an execution context that's been destroyed. It also tells JavaScript that this is an execution context that can now be destroyed. Whereas console log doesn't do that. So here, we're not returning anything. Our execution context would go away, and our output would stay undefined because we haven't returned anything out of that function. So you can use console logs and return statements in tandem. You just have to be careful about the order. So we could do this console log here, and then after it, before that ending curly brace, we could say return also that same math problem there. And it would still print to the console, and output would be defined if we had that return keyword there as well. So you can use them in tandem, and it's really often helpful to use them in tandem, especially if you're debugging something, or you're in, you're in your code and you're like, why isn't this working? It should be, output should be defined. Why isn't output defined? You can do certain things, or maybe output is something that you don't expect it to be. Maybe you're using the return keyword here, maybe we're over here, and let's say output comes out to be 0.85 and you expect it to be 0.72, right? Maybe there's some error in your math logic there or something. You can use console logs to see at different points in time. You could go at each step of the for loop and console log, what is sum right now? What is my current value of I? You can use console logs. They're really powerful for you as developers to debug and to see what's going on inside your code, but they're not for JavaScript to actually evaluate anything or to utilize in that functionality.
What if the return statement was like after the sum equals sum plus, like if it was
Inside that for loop,
yeah, what happens?
what would happen? It would break out of the function.
So it wouldn't go to it wouldn't do the I plus plus.
Right. It would break out of the whole function.
It would just run at once.
It would run it, yeah, it would run it if it was right after this, the sum equals sum, and before the end curly brace.
Yeah.
It would run that sum equals sum plus grades one time, and then it would just return out of the function. The function would, you would never get to that, the averaging part.
Okay.
It would just break out of that. Yep, break out of it all together, which sometimes can be really powerful. So if you're doing something like, let's say, trying to find if any value in this array is 2, return true, right? So as soon as you hit the number 2, you want to get out of there and return true, right? You don't want to go through all the looping. What's the point? You already know that the answer is going to be true, right? So yeah, so it can be super useful to do that sometimes too. So keeping that in mind is really good. Yeah. Because you can do if statements and all that kind of control flow stuff inside of a for loop as well. Awesome. So, in summary, we write code, we run it, we mainly store data and run functionality on it. Our data sometimes that we're storing can be that functionality that we're going to use, right? If we want it to be reusable with functions. Functions let us bundle our work up so that we can redo it all over and over and over again. So, that's basically what I just said. The fundamental pieces, all the kind of language around execution context and call stack and invoking functions. These are like the fundamental pieces of talking about programming, looping and control flow and all of that. You can use all of this stuff that we talked about tonight as you move through these like more and more difficult concepts. But the fundamental pieces are execution context, local memories, global memories, call stack, all of that good stuff. And my last bit on Codesmith, because I love it here. So I don't think I ever actually introduced myself, did I? No. Whoops. Sam is my name. I think I've said it about 15 times now. So I am a lead technical mentor here at Codesmith. So I give a lot of core lectures and more advanced lectures in the Codesmith program, and then I do fun workshops and stuff like this. But then I also am a senior engineer on the engineering side of things, so all the stuff, good fun stuff on CSX and all that, I help build that and maintain it. So yeah, I have a really fun time here, so that's me. I don't know why I'm introducing myself now, because now we're all friends here now already. But anyway, CS Prep is, if you are interested in the Codesmith program, CS Prep is a great way to get ready for your interview, get a sense of what the material is that we cover in the program and the kind of style with which we teach it. So there are two options. There's live online, which is a 2-week remote course, so you don't have to come in here all the time. It's online, it's great. There are instructors Monday, Tuesday, Wednesday, Saturday. So it's like 3 hours Monday, Tuesday, Wednesday, and then it's some other amount of hours on Saturday. Yeah, and it's really great. You go through daily challenges, there are lectures, there's a lot of pair programming, so a lot more of this like what we did tonight. And then, yeah, self-directed is a little more lackadaisical, right? So you can do this stuff on your own time, and there's just more like weekly check-ins and assessments and things. Yeah, and the live online version, the 2-week version with instructors and everything, comes with a project at the end that you actually build with other people. And yeah, and technical interview practice on both things, but yeah, it's really great if you're interested in the program. We're really just interested in like upping your skills a little bit, yeah, and need a little bit more of a push than, I don't know, I'm somebody that definitely could, like, I don't do well when I try to learn by myself, because I'm just like, nobody really cares if I do it today or not, so I just won't, forever. Yeah, so if you just need a little bit more guidance and stuff, yeah, some of these things are great. They're all great, but yeah. And then hard parts, come to hard parts. Even if tonight was a lot, or even if it wasn't a lot, come to hard parts. Join us for hard parts on the interwebs, if anybody is still out there listening to the sound of my voice. Yeah, hard parts is awesome. Even if you come in and don't really fully get everything that's happening, it's still a great way to like come in, join the community. Plus there's drinks after hard parts, and that's super fun.
Yeah.
There's drinks, and if reggaeton's your thing, there's usually reggaeton. Because for some reason there's like an obscene amount of people that Codesmith that really love reggaeton. Not that there's anything wrong with reggaeton, it's just, it tends to be the thing of choice. Plus sometimes karaoke, which again is a kind of a polarizing thing, but is really fun. But there's drinks, so yeah. Anyway, great. Anybody have any questions? Or just like,
How much is your program?
the immersive the 12-week program? I don't remember it this off the top of my head. The last time I looked, it was like $17,500, I think. Yeah,
I
so
think it's going up,
it,
doesn't it?
I don't know. I'm bad at numbers and finances. My wife does all the finances. Yeah, it's the website. It's something along that ballpark line. Yeah, the website has like all the up-to-date information
If you're
for
bad
that.
at finances and you do JavaScript, can we switch brains?
I can do the finance, I just don't do the finance. I'm like, money, it's fine, whatever. I don't have any, so whatever, who cares?
I know, bills, take it away.
I'm like, I don't know, but people are like, but what if somebody like steals your like social security number? I'm like, if they would like all of my student debt, they're more than welcome to it. Go for it. You're welcome. Like, I've got nothing for you to steal.
They should come and take it.
Yeah, I'm like, good, take it, it's yours, fine. No one is gonna give you credit. Like, just fine. Yeah, and then for CS Prep, the cool thing about CS Prep, at least the live online, I'm not sure about the self-directed, but definitely the live online, there are a ton of scholarship. There's also scholarships and stuff available for the program itself. But also CS Prep has a lot of scholarships available, as well as any like non-scholarship funds that go towards the CS Prep go towards your Codesmith like, you know, a tuition then.
Okay.
Once you get in. Never say if you get in, because if you want to get into the program, you can get in. It just might take a while. Yeah, but the interview, because the interview process is tough and a lot of people don't get in on their first time. But you can interview again. You can interview more than once. You can interview more than twice. It's because, again, it's not that we want to exclude people, it's that we want to make sure, like, when you get in, that you're ready to be here, and that everybody's coming in, like, on their game, ready to be here, ready to, handle. It's not an easy thing.
Yeah, it's not.
Yeah. But, cool. Any other questions? Sweet.
When are the hard parts?
Thursdays.
Oh.
So there's online hard parts, like strictly online ones on Wednesdays now, I think we're doing them. So if you want to tune in for them, there's still the pair programming, so anybody who streams in, we just pair you up online and you work together online, on like video chat and stuff. And then Thursdays we have the same kind of this setup where it's on-site and online. 6:30, 7 o'clock, something like that. Yeah. But it's super fun.
Is this going to be a regular weekly or just occasional?
Easier parts? We're gonna start doing it, I think, just about every week. I think there might be like 1 week or so in the course of like 6 weeks or so that it's not. It's gonna be weekly.
Mostly.
Weekish. Weekish, but yeah,
Do you talk about the same stuff or you change them all the time, like the easier parts?
It's usually the same stuff. And the same thing with hard parts. It's the same slides. The thing that gets people coming back all the time is that, I mean, you guys saw, right? You got like through 4 of those challenges, right? So next time maybe you get through 6 of those challenges, and so you come back until you get all of them and even more. Phil, who is one of our fellows right now, he came to hard parts like a year before he got into the program. It didn't take him a whole. He got into the program before that, but decided to he couldn't. He had to wait to start the program. But yeah, he was coming to hard parts like a year. There's people that come like all the time, even once you get the concepts, because it's fun. It's a community.
Oh, yeah.
There's more than 3 people.
Will you consider doing an easier parts on objects?
Yeah, so
Because it's confusing.
so easier parts is still kind of being developed a little bit. You came to like the last version of it, right? When it was still the 2 parts.
Yeah.
So we're thinking about like kind of a long-term goal, relatively short-term goal, but we're still iterating on it. So I think we're gonna wind up splitting it into 2 parts because this is late, right? Like it gets long, and so I think we want to split it up into 2 parts and have a part 1 and a part 2 again. It's just finding, where that line is going to be. But yeah, that one would definitely go into objects.
That would be great.
Yeah.
Because it's kind of a harsh, easier parts and then hard parts.
They throw something in
The
there.
medium parts is what I'm the easier parts and then the medium parts and now the hard parts. Yeah. CS prep also goes into goes into objects and talking about that kind of stuff too. So
Although what you said tonight about objects was
awesome.
was really kind of like, it's a key value with like the key is the index, and it's like suddenly it made sense.
Yep, exactly.
On some level.
Yeah, it's in other languages too. So sometimes I think that JavaScript is less than descriptive, or less than ideal in their terms for things. But because for example in Python, objects are dictionaries, which I think makes a lot of sense, right? Like the term for an object, like the equivalent-ish of that in Python would be a dictionary, which I think is really interesting because it's the key in the dictionary and then the values, it's like the kind of the definition for it, right? And then arrays are just lists in Python, which list. It's a list of stuff.
So much easier.
But we love JavaScript because it is so versatile. It's very great. It's also just fun.
Can you self-teach just like Python?
Can I?
No, I
Can I mean, you can do anything, right? You can teach yourself to be a lawyer.
Oh yeah, well.
No one can stop you. They might stop you from practicing law, but theoretically you can teach yourself everything the law school teaches you. You can, there are plenty of people who self-teach Python, JavaScript. It's one of those things where like, because I self-taught for a long time, and I found it really easy to get to the easier parts of any language on my own. It's when you get into nuances of like under the hood, execution context and call stack and memory allocation in certain languages where there's like, you have to actually open up the space in memory. The engine doesn't do it for you and all this other stuff. Like when it gets into things like that, it's just really tough to find resources to teach yourself that, let alone really fully understanding it when you find them. Yeah, because there's like documentation pages and stuff, right? Like you can go read the Python documentation page and the JavaScript documentation pages. But yeah, it's one of those things where you kind of just have to like either work in it or work with people, and yeah.
It's so hard to kind of like understand this stuff. Like every time I do MDN, I have no idea what they're saying. It's just even more confusing.
Yeah.
I need someone to teach me how to read that. So.
Bye, internet. Maybe if I can figure out this.
Thank you so much.
Yeah, thank you guys.